Okay, this is Mr. Long, and we are going to go through a moles A, moles B problem. But first I want to balance a combustion equation. So we have C6H6 reacting with oxygen to produce CO2 and H2O. So you put carbon and hydrogen and oxygen under the arrow, and understand we're going to balance oxygen last and hydrogen next to last. So let's count up our atoms. We got 6 carbons on the left and 1 on the right. And then we got 6 hydrogens on the left and 2 on the right, and 2 O's on the left and 3 on the right. Now we are going to put a 6 right here in front of carbon dioxide. So 6 times 1 carbon is now going to be 6, so that takes care of carbon. 6 times 2 oxygen will be equal to 12, plus that 1 is equal to 13. So now we have 13 oxygens. We can balance hydrogen, so we can put a 3 as a coefficient in front of H2O and remultiply. 3 times 2 is going to be 6, so that's good. And 3 times 1 is 3, plus the 12 over here is equal to 15. So now we have 15 oxygens. Now we have an odd number here, and everything else is even. So when you have that, you're going to double everything. So this is a 1, so we're going to make this a 2. This is a 1, we're going to make this a 2. This is a 6, so we're going to make this a 12. This is a 3, so we're going to make this a 6. So now we've got to remultiply. 2 times 6 carbons will be 12. 2 times 6 hydrogens will be 12. 2 times 2 oxygens will be 4. That's easy enough. And now we've got 12 times 1 will be 12 carbons. 12 times 2 will be 24 oxygens. And 6 times 1 will be 6 oxygens. That's 30. So now we got 30 oxygens. And then 6 times 2 is going to be 12 hydrogens. And then just to balance this out, do an oxygen last. So you have to put a 15 here. 15 times 2 is going to be 30. So now our coefficient ratio, 2, 15, 12, and 6. We know this is combustion. Now, pause anytime that you want to take a look at it, rewind, catch up. Now, so this is going to be a moles A, moles B problem. Well, let's say we have 5 moles of C6H6. How many moles of CO2 will this produce? Now you think it's going to be hard, but it's not. We've got our mole ratios right here. We get 2 moles of C6H6 in the balance equation, and we got 12 moles of CO2. So we're going to start with what we're given in any problem. So we got 5 moles C6H6, and we're going to put moles of C6H6 on the bottom, and we're going to moles of CO2 on top. And since this is a moles A to moles B problem, and we're using the coefficient ratio of the balance equation, it's really rather simple. Start with what you're given, put that same unit, whoops, I'm sorry. Let me go back then. We have 5 moles of C6H6, and we're going to put moles of C6H6 on the bottom, because that's the same unit as what's on top here, and we're going to moles of CO2, because that's what we're looking for. So We're going to get these numbers from the balanced equation. And we know what that is. So for moles of C6H6, we know that was a 2. So we're going to put a 2 here by that. And for CO2, we know that was a 12. So we're going to put a 12 here. Now, we know that unit's going to cancel out. 2 ways to do this. You can either say 12 divided by 2 is 6. 6 times 5 is equal to 30 moles of CO2 produced. Or you can do 5 times 12. 5 times 10 is 50, plus 5 times 2 is 10. It makes 60. Divide that by 2 is equal to 30. Now, I would almost always want you to write it, so if you're doing this the second method, 5 times 12 divided by 2 is equal to 60 divided by 2, which is equal to 30. I want you to show that work. I just didn't write it at first because there are 2 ways to do this. This is our answer here. It's a moles A to moles B problem. So those are really easy. You just get the balanced equation, look at the numbers in front of the compounds or the elements, and put them in there. And I forgot to box up the puppies here. So I'm sure some of you already did that. Let's box them up. And there we go. Okay? So that's a moles A to moles B problem.
Using this good grammar and spelling are important. But if you want to write essays that inspire, messages that forge bright.
Okay, so now I'm going to do a whole bunch of mole ratio problems, a whole bunch, so that you can really get a handle on these. They're super gives us 2 moles of this and 1 mole of this. But we're not talking about starting with 2 moles of H2O. We're talking about starting with 6.2 moles of H2O, okay? So this is just like when you're cooking and you
Okay, for practice here, moles A to moles B. You have 3 practice problems. Remember, these are easy. You're just going to use the molar ratios in the balanced equation. We're not using the periodic table. So on this first one, you're going to use 2 moles of SO3, and it's going to break down through a decomposition reaction to 2 moles of SO2 plus 1 mole of O2. So your mole ratio is 2 to 2 to 1. So your question is, on this problem, how many moles of SO3 are needed to produce 10 moles of O2? So all you're going to do is start with 10 moles of O2 and use the mole ratio. Cancel your units. So you can pause it there and copy that down. Second one, we have the decomposition of water. to produce hydrogen gas and oxygen gas is a 2 to 2 to 1 ratio, mole ratio, coefficient ratio, molar ratio. And how many moles of O2 will be produced from 17 moles of H2O? And then problem 3, for moles A and moles B, you have 2 parts of H2S reacting with 3 parts of O2 to produce 2 parts of SO2 plus 2 parts of water. So those numbers, 2, 3, 2, 2, that's the what now? It's the molar ratio. All right, how many moles of O2 are needed to combine with 12 moles of H2S? So you're going to have 12 moles here, and you're looking to how many moles of O2. So that can get the question mark. So you can do this over your other problems as well. Okay, you're just going to take this ratio here. So you start with 12 moles of H2S and use that ratio. That's all there is to it. So when you go ahead and do those practice problems and have your answers there in your notes, and I'll let you know when to send them to me. But I'm going to do several more videos on this. So let's get ready to roll. Let's see what we can do here.